Mr. McLogan, Johnny says, I'm just a bit confused on how to get the domain of f circle g function. I can explain that rather quickly. So it doesn't really matter what the domain is, like when you're trying to identify, or what the functions are. So basically, I mean, well, it does matter. But my point that I'm trying to do is when you're trying to do the composition of f of g of x, which is, again, basically f of g of x, right? You're basically plugging the g of x function into the fx function. So to identify this domain, what you need to do is you need to find the intersection of two domains, g of x and f of g of x. Okay, so you basically just need to find the domain of g of x and f of g of x. So let me give you an example. I guess might as well just finish this off. Let's pretend g of x is the square root of x, and let's pretend f of x is 1 over x squared. All right, so the domain of g of x is going to be all numbers that are greater than or equal to 0, right? And for f of g of x, when you plug those in, when you plug that in, you're going to have 1 over square root of x squared, which equals 1 over x. So that's going to be all real numbers except for 0. So again, we're trying to find the intersection, right, of combining these two. Well, again, the values have to be greater than or equal to 0. But this one's basically saying all numbers that are in the domain are going to be from -infinity to 0 or 0 to infinity. Well, the only domain that's actually intersection, you'd have to graph these, I think would be better to see this, but you can see the domain here is just going to be from 0 to infinity. So that's just a really quick explanation for you, because again, guys, as I apologize, I have some enters to get in.